Now we are going to use MATLAB with quiver command to draw a slope field of a differential equation. So here dy dt stands for the slope, and you know that so dy dt is the slope. So what we have then is that this quantity here would be the slope, that is m, and then what that command that I mentioned, the quiver command, would do is that, or quiver in MATLAB is going to do this for you, that at each point, okay, so at each point, all right, ty, it will go ahead and draw, or rather draws, that's what quiver does, draws a vector with components, okay, so with components 1m. Now if we did this, say if we just go ahead and take the vector with components 1 divided by square root of 1 plus m square, which is the length of this vector, then we shall get a unit vector at each point, giving us the line segments with the slopes given here. Okay, so let's go to MATLAB command window, and now here is our slope or the differential equation here, and we are going to use quiver to obtain the slope field. So what we would do is this, that we will take a bunch of values for t and y by using mesh grid, okay, and let's just stay simple, say go in the steps of what, say, or let's just go from 0 to 4, okay, in the steps of 0.2 or in the increments of 0.2. If that doesn't look fine enough, then we would refine it. Okay, now we have to put the symbol here, otherwise it's going to print the output for us. All right, and now we are going to define the slope as t plus who, sine of y. All right, and we don't want to see a printout with slopes, so let's suppress that, and let's go ahead and take up the length of each vector. And what is the length? 1 plus, now remember this, we are going to take a square of m, and since we are doing this on the grid and want to do this element wise, we have to use this dot command. All right, and then suppress the output. Okay, and now we are going to use that quiver command. All right, let me see if I spelled it right. Yes, and it tells us what to do. So that is, we will have a t, y, and then I'm going to say that give me the vector with the first component as 1 over L, and we have to put the period before, sorry, that portion, right? Okay, and let's see what this gives us. Okay, so here we have a vector field now, right here, nice looking vector field, and we can go ahead and refine it, change the lengths and all that. All right, if we do this, if we say axis tight here, okay, say axis tight, then we have a final graph, right? Okay, so this is a vector slope field for this differential equation. Now say we would like to draw or overlay graphs of some initial value problems involving this differential equation. Okay, so for example, say we want to do this, that is, this is the differential equation, and we want the curves that show the solution curves according to these initial conditions overlaid in this slope field. So what we would do is this. First thing we would do is that we will ask it to hold on to the graph. All right, and now I'm going to again define an anonymous function. Now when I'm defining an anonymous function, I have to use different symbols because I already use these two up in here. So simplest way would be, let's just use some other letters. All right, so this is what? U plus sine V. Okay, so we have the anonymous function, and then what we would do is this, that we will just ask ODE 45 to give us the solutions. Okay, and then what we have is, let's keep, you know, the independent variable ranging in some steps from 0 to 5. And now we want here 1, 2, 3, and we can write them in a single command. That is 1.3 is going to do this. That is would give us these three conditions here. They will be entered in this place. All right, so we got this, and then we will say plot UV. Okay, and now we are going to say hold off. Okay, and let's see. Yes, we have the graph, but our windows are different. We can do this here, that we can just write, and you can have, you know, much smarter ways of taking care of that on your own. But let me just settle this with this. Okay, that is, we want to restrict the axes with these. So then what happens is, yeah, so the axes are from 0 to 4 and to 0 to 4. And if you want, I can also say axis, we already had it tight, so say equal. All right, and then the, okay, well, again, all right, I mean, let me just put this again here and not mess with this because it's getting too late for me. Okay, so here everything is here, and we can just now go ahead and edit the plot. Okay, let's just choose these guys. Okay, and change their, well, they are already solid. I'm just changing them to black. Okay, and then I'll change their width to 2. So here these solution curves are plotted in here.